So our next trip down our little food journey here is going to be the stomach. So this is where chemical and mechanical digestion are going to continue. So remember, so far we've only been breaking down carbohydrates with that salivary amylase. And it actually continues as it goes down the esophagus. It's continuing to work on those little carbohydrates. And really in the esophagus, there's no mechanical digestion happening. So once we get it into the stomach, we are going to start that mechanical digestion again, and we are going to begin some new chemical digestions here. The salivary amylase is going to keep working in the stomach to a point. Once that stomach gets super acidic, salivary amylase is going to stop working. And then what switches over is going to be the digestion of protein. And also we're going to have very limited amount of fat digestion working here. It says beginning, but there was a little bit of lingual lipase secreted in the mouth. Didn't do much, but neither does the gastric lipase. It doesn't do a whole lot. I think gastric lipase is the one that works more on the butter fats. So as we move into the stomach, this is going to be where the ingested materials spend a little bit of time, not as long as they will in the intestines, but they do spend a little bit of time here. 2 to 6 hours here. Some things are going to move a lot faster through than others, like fats tend to stay in the stomach a lot longer. Another thing is going to be, we really don't have any absorption happening here. A lot of people say, oh, the stomach, yeah, it absorbs a bunch of our food. Actually, no, it doesn't. It doesn't really absorb any food. You have absorption of non-polar substances. You have things like alcohol. Yeah, it'll be absorbed into the stomach. And also medications like aspirin will be absorbed across the stomach wall as well. That's why they tell you if you take a lot of aspirin, you have to watch for gastric bleeding because that's where it's absorbed here. All right, so let's take a look at the anatomy of the stomach. So as you can see, it's a J-shaped organ, and there's going to be 4 areas that we are going to be taking a look at. First, let's take a look at these curvatures that we have. We have a lesser curvature, as you can see right here, and then we have a greater curvature on this side. So as far as the areas, you are going to have that cardia right here, and sometimes referred to as the cardiac region, but there's the cardia. That it's a pretty small area, and that is going to be where the food first enters in from the esophagus, and that's right where that lower esophageal sphincter is going to be as well. It's going to come from the esophagus. It's going to dump right into the cardia. It's probably not large. I probably didn't draw it large enough, but it's actually kind of small here. The cardia tends to secrete a lot of mucus right here. So we do have a lot of mucus cells. And the reason why, it's because when it opens up to receive the bolus of food, we want to make sure that if there is any kind of acidic chyme in there that, and it does kind of move up because the stomach kind of mixes and churns whenever there's food in it. And if there happens to be acidic chyme that does kind of move up, then we want to protect that lining of the esophagus. And that is why we're going to have a lot of mucus that's going to be secreted right here. The kind of hump portion is going to be the fundus. And we'll actually see this in the reproductive system. We'll see a fundus on the uterus. It also has kind of a little hump right there. Food tends to kind of, whenever it enters in, it tends to kind of float right up here. This is where gas bubbles get caught as well, is going to be in the fundus. So if you drink soda, this is where all of your little gas bubbles are caught. And if they do accumulate too much, then your body's going to want to get rid of them, and that's where that is going to come up, and that is how you are going to burp, is because you have all those little gas bubbles that are collecting up there in that fundus. That pressure gets so great that it's actually going to force the sphincters open to force you to burp it out. The largest portion here of the stomach is going to be the body of the stomach. And really, what we have here is lots and lots of different cells that are going to secrete the different enzymes that we'll talk about, the hydrochloric acid, the mucus, and things like that. And then the very last part is going to be the pylorus. So the pylorus is going to be right in here. And you have our next sphincter. So the pyloric sphincter is going to be right here. This is going to be what controls that movement of chyme from the stomach to the duodenum. And this is really, really important sphincter because we'll talk about regulation of the stomach stomach movement, I guess I should say. We're going to talk about how we are going to secrete just a small amount of that chyme at a time from the stomach into the duodenum. It's very closely regulated. Look at the little gastric folds right in here, as you can see. These are called rugae. And this is something else we'll take a look at in other structures, like, well, I think we looked at it already, actually, in the bladder. Bladder had rugae. But also we'll take a look at it in the vagina as well. What these are is, these are going to be folds. Obviously in the vagina, they're not gastric folds, right? So, but you caught that. So rugae are going to be these folds that are going to allow the stomach to expand. So if we do fill up rather quickly, then the stomach is going to expand. So the folds are going to be more prominent when our stomach is empty, and then they are going to almost disappear whenever our stomach is full. So these are actually temporary folds that are going to be found in the stomach. What's interesting about the stomach is, whenever you get a stomach ache, it's usually because you do have some pain receptors in your stomach, but they're not triggered until your stomach gets so full. That's where it's going to trigger those pain receptors to where you get that kind of tummy ache. So typically those pain receptors aren't triggered unless, of course, you have like a stomach bug that's going in and irritating the lining of the stomach, or it fills up, and then that pressure just pushes on those pain receptors so much. All right, let's take a look at the histology. So look at this. This is a really interesting picture right here. You can see how abruptly that epithelium changes. Look at it. It's all stratified squamous over here, and then all of a sudden it becomes simple columnar. So it's really interesting how quickly it just goes from one to another right there. And we'll talk about these folds right in here, these gastric pits that we're going to be taking a look at. But the simple columnar epithelium is going to be there for, of course, secretion mainly, and a little bit of absorption. Remember, just a little bit here in the stomach. So the gastric glands are going to extend way deep into that mucosa, and we'll take a little bit closer look at another picture, another drawing here in a second. And it's partially surrounded by the muscularis mucosa, and that's going to help kind of squeeze a little bit and influence those cells to secrete what they need to secrete. All right, so this is taking a look at a drawing, as you can see. So this is showing that rugae right here, you can see it, and then you can see that gastric pit is going to be right here. And we are going, in a second, we are going to zoom in right here, and we are going to take a look at all of these different cells that are located in the pits. There's that muscularis mucosa, and that is going to, again, it's going to be sitting right next to these cells, all the little blood vessels right here. We will talk about this lacteal, that lymph vessel, in a second. And what we'll also talk about is this new muscle layer right here as well, that oblique layer. Speaking of which, right here. So the oblique layer is going to be here. So that's going to be the innermost layer, and you still have that circular and longitudinal layer. And what it does is it's just going to help with the churning and the mixing motion that we have here. And we'll talk about the different movements, these muscular movements that we have in the stomach later on. What's interesting about it is that the muscle, this muscularis layer, actually becomes thicker as it goes away from the body to the pylorus, and we'll talk about how important that is because it's going to help push food a little bit, push food from the body to the pylorus. And then, of course, you have the last layer, which is going to be that serosa.